Hello everyone. Once again, this is Mr. 13 Things coming at you with how to use or why we promote perhaps antiquated technology in the TI-83, but why it's still great stuff to do simple things like writing your high school as #1 and making it rotate and move and do all kinds of stuff using the same set of skills that you have gotten introduced to you since second grade, that being transformations like rotation and reflection. I'm going to cut out around the edges here, though you see off on the left a emulator, the TI-83 calculator, downloadable. I've erased some of my really cool tools. I'm not going to erase that. I'll just kind of go here and erase the rest of this. Can't do that. Click back and forth. I'm using what program? I am using now something I can't manage. So I'm just going to work in this area right over here. So to review, we are looking at the letter A. Remember that one from Sesame Street? All right, the letter A basically in a box, a bounding box that's 100 by 100, is a matrix that looks something like this. That matrix, the bottom left point right here on the A has coordinates of 0 in the X, 0 in the Y, 0 in the Z, and you have a 1 scale factor you carry around. The first point there, which is point 2, has coordinates 25 and 50 in the Y and 0, and it has a scale factor of 1. The apex of the A, if you would, that point there, has coordinates of 50 in the X and 100 in the Y and 0 in the Z and 1 in the scale factor of 1. And then this next point down here is, in fact, it is 75 in the X and 50 in the Y and 0 and 1 for a scale factor. And finally, it has coordinates of 100, 0, 0 in the Z, and 1 here. So this is, in fact, our point matrix, if you would, which is a collection of point vectors with a scale factor. Vector 0.1, 0.2, 0.3, 0.4, 0.5. And one thing you do want to be aware of, that the bad thing about the TI calculator is that it starts counting things in a list by spot, row, or column 1, where many other real programming languages begin at 0. So what you're going to do there, this is your point matrix. And what you want to do for animation is move that around, doing something here that we're going to call a transformation matrix. Transformation matrix. And all transformation matrices begin with, in your head, the identity matrix, which is just very often written like this. It's zeros above a diagonal, and then you change some of these things out. So let's see how we go about doing that in the calculator, and hopefully this will work. We are here on the TI-83 calculator, downloadable from TI. I'll try to put the link here for you. It is a free download. You can get them at the end of the school year when students are throwing them away who didn't learn how to use them. They'll give them to you for 30 bucks on eBay. TI-84 Plus has a lot more memory. You're looking at somewhere between $90 to $130 new, freely available for now. And most of you just want to get the concepts down, but you also do want to start to realize why, in fact, many of us love this calculator, along with a few others. So amongst the things we always do when we get a calculator is we go over here, we turn it on, we hit clear, and very often you're going to see you ask it a question you know the answer to. I say tangent of 45. If you don't know what the tangent of 45 degrees is, it's 1. Learn it, so when you get that answer, you know it's wrong. Out of habit, I'm going to go ahead and change the mode. And the habit of starting the calculator or a machine each and every time, asking it a question you know the answer to, and making sure you get the right answer. We can do another one, tangent of 45. This is not even necessary, but it's habit. Every time you turn on a machine, we're going to clear it. We're going to do one more thing. We don't want to see a lot of numbers here, so we're going to go ahead and just put actually it so it shows nothing right at the decimal place. Our point now is to put in our matrix, and we're going to go ahead and put this, we're going to call this matrix B. These are going to be our points, and matrix A is going to be our transformation matrix. We're then going to talk about how to change the transformation to transform this letter. So how do you go about doing it? There's lots of different ways, but learning very quickly how to manage second matrix function keys is not beyond any student. And we're going to go to matrix B. We have to go to edit. A little bit clunky, you could go there, and we want to now tell it this is a 4 rows by 5 columns, 4 over 5 columns, and unfortunately that will fall off the screen, but that's fine. And realistically, it's a good idea for students to put the vectors in individually. So go 0, down, 0, down, 0, down, and remember the 1 scale factor, a very common error. You're going to go across to the top now. The second is 25 in the X, 50 in the Y, it's 0 in the Z, and the scale factor of 1 again. The third vector is 50, or a point. And the concept that a point is the end of a pointer is probably a tough concept for maybe a lot of the teachers to get. Some of my military students had a hard time with that. But the fact is, a point is the end of a pointer is one way to talk about that. 100, go back here, 100, going down. This can be frustrating to start. Perhaps you want to do it on a spreadsheet, the new technology. On the other hand, the new spreadsheet is not allowable in a lot of exams. It is not as portable, and you can't surf on a TI-83 calculator yet. The next point is 75 in the X. It is 50 in the Y. It is 0 in the Z. And once again, the scale factor of 1 is going to be odd for some. And finally, we're going to go to the last point to enter there, and we're going to go back to the top. And that point is 100 in the X, 0 in the Y, 0 in the Z. And we cannot forget to double check that we have a 1 for the scale factor. Matrix B, second quit is how we end the matrix. Second matrix, I'm going over to B here. And later on, you're going to really look at these things by plotting them. So now you've gotten matrix B. Now let's look at matrix A. And what we can do is multiply A times B to get the thing to move, rotate, to do our basic reflections, our basic transformations. So we're going to go same thing, second matrix. This time we're going to go to edit, and we're going to edit A. Our transformation matrices will always be 4 by 4 if you're using the standard kind of augmented matrix. And what we're going to tend to do with students, beginning or middle or end, is to always start with the identity matrix. There are faster ways to do this, but you want them to start with the 0 matrix and put 1s across the top, or 1s down the diagonal. Second quit, you now have A times B. If A is the identity matrix, A times B should be B. So second matrix A, without using the multiplier, second matrix B. And you see it turns out to be the same thing. Final step here, remember when we're looking at this, see if I can use my little dealy bopper here. I notice I can't over there. The fact is that for our transformation matrix, that's going to be the rotation and scale, and this vector here, 1, 2, 3 things, is going to be how we want to translate. So now let's assume we want to move our letter. This is the letter A, which is stored in matrix B. That could be a little confusing. All right, we want to move it, well, more than 100. Let's say we're going to have a finger space of 100. We want to move it 200 to the right. How do we go about doing that? So let's take a look. You go back to your second matrix, and you're going to go to edit. And the one you're not going to edit the matrix that describes a letter. Anyone could do that. You're going to use the mathematics of a application or multiplication of a transformation matrix by times a point matrix to get the new point. So you're going to edit A. In this case, you remember, you're not going to deal with the rotation scale, which is 1, 2, 3, those kind of 3 to the up to the left. You're going to go to the translation, and let's say you wanted to move it to 200. You would add that 200 there. It is, everything else is the same. You say second quit. And now if you do this, second matrix A times second matrix B if you look at that, you see that it actually has moved everything by 100 or 200. What did it do? 300. It was starting at 1. It moved them by 200. So let's go back and look. Did I do that correct? Second matrix A. I'm going to look at that. What does that look like? It's 200. It moved everything by 200. By applying and multiply a transformation matrix, and here now you can get to maybe one of the more important concepts, is that every matrix, like most numbers, have a multiplicative inverse. In mathematics, if you multiply a number by its inverse, you get the number 1. In matrices, if you multiply a matrix by its inverse, you get the identity matrix. But if you're looking at transformations, if you multiply something you transformed by the inverse of the transformation, it should go back to where it started. So to finally end with this, I'm going to go ahead and now multiply second matrix A with a second matrix math transformation times second matrix B. Now if you remember, second quit, do this again, times second matrix. If you remember, I didn't store what I was doing. So this is, one more time, second matrix B. And what should that do? It should move everything to the left 200. And if you think about it, I think it did. Perhaps it did store it. So if you notice there, the numbers along the bottom would tell me that I did something wrong. I think it's B times A. Let's take a look. Second matrix, let's see what matrix B looks like. So that all looks well and good. 0. If I want to move it now, if I go second matrix, let's take a look at what matrix A is. And matrix A should be all ones, and then 200 there. If I'm I am wrong on the transpose, so I apologize for that. It has to do with the way this is lined up. Thanks for listening. So we'll kind of have to clean this one up a little bit and step back on the transformation inverse.